with that continuation, so now we are going to see about the perceptron function. So the perceptron function that maps its input x, and which is multiplied with that learned weight coefficient. So already we know what is the purpose of mx plus b. The same way we have denote this perceptron function with wx plus b if its value is greater than 0, in case the f of x is 1, if wx plus b value should be greater than 0. So if that f of x of value is 0, then that has to be treated as null. So the input x, it should be multiplied with that learned weight coefficient. So it is called that w, and that input x is an input value, and then the b be treated as the bias. So here the w is equal to vector of real valued weights, and b equal to bias, an element that adjusts the boundary away from origin without any dependence on the input value. So x equal to vector of that input x values, that is already we know. So now the function can able to rewritten as a summation of I is varying from 1 to m, and we have to be multiply the weights along with x, that is wi into xi. So m is the number of the inputs to the perceptron. So the output can be represented as either 1 or 0. It can also be represented at what we see earlier by +1 or -1, depending on which the activation is used. So this is the basic constraint of the perceptron function. And now we have to see what is activation function of the perceptron. So already we are having three set of the stages in perceptron. We studied that is earlier. First one, we are having the inputs, and second one, appropriate weights, that rises from w0 to wm, and then so the summation part is called the summation of I equal to 1, it's varying from varying up to that m, and multiplication of wi and xi. And finally we have to go with that activation function. So this activation function, that should be greater than 0, already what we said earlier. So the final output should be that 1, or the output should be that -1. So there is the three varieties of perceptron function. The number 1 is called, that is the step function. In that image itself you can able to see that falls into the positive quadrants of the graph. Already we studied in the earlier schooling. We know the graph is having a 4 quadrant. The first quadrant, the x and y is the positive quadrant, and in a second quadrant we are having that x is positive and y is negative, and in in the third quadrant we are having that x is negative and y is also the negative, and in fourth quadrant we are having x is negative and y is the positive. In that same way, that perceptron function is also defined. In that step function, it's mentioning into that +1 kind of that variety, and in that sign function, that has been ranged from -1 to up to that +1. And we are having that another one function is called, that is that sigmoid function. Already we know the sigmoid that has been placed in between two dependent variables. It may be f0 and f1. So one kind of that dependent variable may push into that +1, and another one kind of that dependent variable can able to be put into that another part of, that is in the x coordinates of that +1. So these are all the three varieties of that activation function in that perceptron. And now we have to quickly see the inputs of a perceptron. So a perceptron accepts inputs, moderates them with that certain weight values. Already we said that one applies the transformation function to output as the final result. A Boolean outcome that has been the output of the perceptron, such as for that inputs like salaried, marriage, age, past credit profile. For this parameter, we are having that only one answer, either yes or no. Are you salaried? Yes or no. So are you married? Yes or no. So what's your age? That's an above 30? Yes or no. So past credit profile, is it good or bad? So the outcome always based on that only one answer. The answer either be positive or the answer either be negative. So it has only the two values, that is yes or no, or we have to say that is the true or false. So the summation function multiplies all inputs of the x by the weights of w and then adds them up as follows, that is w0 plus w1 x1 plus w2 x2 up to that wn xn. So this way the input perceptrons that has been computed. So now we have to be see how that output perceptron is working. So the perceptron with that Boolean input, so that means x1 to that xn, and that output we are having the weights that has to be multiplied with that x1 and that xn. So output of x1 up to that xn, that seems to be if it is 1, and if w0 plus w1 x1 plus w2 x2 until up to that wn xn, that weights should be greater than 0. If it is that minus 1, that has to be that otherwise. So the weights wi equal to the contribution of that input xi to the perceptron output. So wo is bias or that threshold. If the summation of I into x, that means wx is greater than 0, the output is positive. If it is less, that output is that minus 1. So the neuron, it gets triggered only when weighted input reaches to the threshold, certain threshold value. So output of vector of x equal to sigmoid of w vector of the w, that should be multiplied with that vector of that x. So signal of that y equal to 1 if y is greater than 0, minus 1 or otherwise s. And output of the plus 1 specifies that neuron is triggered, and output of that minus 1 specifies that the neuron did not get triggered. So SGN stands for that sign function with that output of with the plus 1 or minus 1. On that continuation, we are going to see about the decision boundary.